Hi, everyone. So an example for two-way Anova, two-way layout with interactions. Okay, so this is the sample data. So this is the data for plants. And the location is the first factor. Maybe I would say I. And the fertilizer is the second factor, J. And the growth is the response variable. I would say Yij. And I is either south or north. And J is either no or X or Y. And we have all pairs. And actually we have 2 observations for each pair. So in total, we have 2 I's and 3 J's, so 6, but we have 2 observations each. So actually the K is equal to 1, 2, 2. So I would say this is alpha ijk. So this is maybe we can write maybe that we use X, so the X ijk. So this is equal to the X111, and this is X112 up to X232. So we have 12 observations. And at first, we will see whether this location and the fertilizer have interaction or not. So this is interaction plot. So the south exposure, we have this result. So we have no fertilizer or fertilizer X or fertilizer Y. And no and X, none and X don't have much difference, but the Y have a large difference. And for fertilizer, for north exposure, the north field, the curve is a little different. So actually the fertilizer X and Y also, both work almost in the same way. And both are much better than none. So that means probably we have to consider the interaction between location and fertilizer. So fertilizer X only works for north location. Yeah. So this is the linear model or the two-way layout. So Xij here, the growth is equal to the first factor, location, and second factor, fertilizer, and the interaction. So interaction that we should use the first factor times the second factor. This is pretty intuitive, the coding. And we get the summary of this Anova model here. And the location, so our language in default that we assume that the alpha 1 is equal to 0 and beta 1 is equal to 0. So at first we have basically the intercept mu and the alpha 1 hat and the alpha 2 hat, beta 2 hat and the beta 3 hat. So these are the estimate. So the baseline is 12.5. If no fertilizer and the north exposure, then 12.5. If the location is south, the 3.5 additional. And if fertilizer X, the 3.5 additional growth. Fertilizer Y, the 3 additional. But if we combine location of south and fertilizer X, we subtract 3 because X only works for north. And if the south and Y, we add 1. So Y, fertilizer Y, that works well, actually the better for south. So this is the model. So basically this is the mu south is 2. So the gamma, excuse me, 2 and the gamma 2, 3. So these are the enough number of parameters. So in total, we have 6 parameters. So the linear model that works for this two-way layout with interactions. And here is the Anova table. So we test. So we have several lines. So location, fertilizer, location times fertilizer, and residual. So we want to test at first. Okay, so the most basic model is the xijk k is equal to mu plus epsilon ijk. And then the xijk is equal to mu plus the alpha I plus epsilon ijk. Then xijk is equal to mu plus alpha I plus beta j plus epsilon ijk. And xijk is equal to mu plus alpha I plus beta j plus gamma ij plus epsilon ijk. So we have the several test result, and this corresponds to these hypotheses. So suppose that we have the assumption 1, 2, 3, 4, the model 1, 2, 3, 4. The first one compares the 1 versus 2. So null hypothesis is 1 and the alternative is 2. So here the probability is, p-value is 0.18. So that means that we cannot really reject the null hypothesis. So maybe the mu plus epsilon is sufficient. But note that we only have the 12 observations. So if we have increased the number of observations, it's very likely that we can get the more significant p-values. Then the same thing for 2 versus 3 and the 2, 3 versus 4. So we can test these hypotheses sequentially. So this is the two-way analysis of variance. And if we change the order of these two, the first two, actually the result does not change. Basically, we can separate the effect of the first factor and the second factor. Yes. So this is the case, and I will explain these quantities later. But this is kind of the sum of squared for a little bit more complicated one. So two-way analysis of variance without interaction term, that we defined the sum of squared residuals for exactly this one, and this one. But here the formula is more complicated, and I would not explain this, but we have a similar formula. And later in the chapter, you can see how these are calculated. And the mean square, so mean square is this sum of square divided by degrees of freedom. So you can see, for example, this line, 12.33. So this is 24.667 divided by 2. And the same thing for other observations. And the same for this. And f value is the ratio of the two. So this f value is calculated by this divided by this. And degrees of freedom is 1 and 6. So this follows f distribution with 1, 6. So you can calculate the probability, the p-value for this. So this is the upper probability for this f value. So in this way, that we can calculate the all p-values, and we can test these hypotheses sequentially.